Welcome to Learn Digital Way. You know, there's a specific feeling you get when you read a really good fantasy novel, or maybe when you watch a movie like Blade Runner or Lord of the Rings, that sense that the world extends beyond the frame. You look at some building in the background of a shot, or you read a description of a city, and you just think, I could walk in there. People live there. That place has a postcode and a sewer system. There's a whole world happening that you're just getting a tiny glimpse of. And that's what separates a good story from a truly immersive world. The belief that what you're seeing is just a window into something so much larger. I call it a world building. Not bricks and mortar, but rather polygons and pixels. I am looking at the architecture of the future. And I don't mean real buildings. I mean the architecture of digital reality. We're looking into Boundless Fidelity, the power of Unreal Engine. And I have to be honest, when anyone would see the title, they will think, okay, this is for video game developers, tech-heavy stuff, frame rates and texture buffers, things only coders care about. This feels much, much bigger. And that's the first thing that needs to be said clearly. If you think this is just about the next shooter game you're going to play or the next graphics card you need to buy, you are missing the point entirely. This technology, Unreal Engine, is not just as a game engine, but as a foundational tool for creating reality itself. That sounds like something straight out of science fiction. I am not talking about levels or high scores or boss fights. I am talking about experiences. I am explicitly broadening the scope beyond gaming into something far more substantial. I am talking about changing the fundamental way humans interact with digital information. So the mission of today's session is to really unravel what this technology is promising. Boundless Fidelity is all about changing the scope, the look, and the actual process of creation. And to make sense of it, I will break it down. There are three core pillars. If you want to understand where digital interaction is going, whether that's the metaverse, the future of cinema, enterprise simulation, whatever, you have to understand these three things: scale, fidelity, and workflow. Scale, fidelity, workflow. It sounds simple when you list them like that, almost like corporate speak. But as we really dig in, and what struck me most was this idea of a convergence. On one side, you have game-changing fidelity, making things look indistinguishably real. On the other side, you have artist-friendly tools. Historically, those two things have been at war with each other. They've been on opposite ends of the spectrum. Usually, if you want something to look incredibly real, it is incredibly, punishingly hard to build. It takes a team of technical wizards months. This gap is closing, and closing fast. So first, we'll look at the size of these worlds, the philosophy of scale. Second, we'll talk about how real they look, the fidelity, and the specific technologies, Nanite and Lumen. And third, we'll look at how they're actually built, the creative revolution, the workflow, because the how is just as important as the what. Section 1. The philosophy of scale. Let's just say, build bigger worlds. Think big, really big. It's almost a dare. It feels like someone throwing down the gauntlet to creators, to artists, to developers, saying, we've built the tools. Now, what can you do with them? But let's be honest. Every tech company says, think big. It's on motivational posters in every office in Silicon Valley. So what's different about this specific call to action? What are they actually asking us to move away from? To answer that, you have to look at the psychological history of gaming and digital simulation. For decades, we've been trained, absolutely conditioned to think in boxes, literal and figurative boxes. If you're a level designer or even just a player, you instinctively know you have a memory budget. You can only have so many trees on screen. You can only see so far before the fog rolls in. The classic fog. It is to hide the fact that the world just ends. The fog is there to cover the edge of the box. We've been designing inside these limitations for so long that it's become second nature. You walk down a hallway and there's a door that's just a painted texture. You can't open it. It's a fake door. You look out at the horizon and it's a flat picture of mountains. They're not real mountains you can walk to. We're used to what I'd call claustrophobic design, designing around the limitations of the computer, putting up invisible walls because if the player walks past that specific tree, the whole system will grind to a halt and crash. So think big, really big, means creating truly expansive worlds. What it's really implying is the removal of those walls, the removal of the box. It suggests a fundamental move away from those constrained, claustrophobic environments and into something that feels boundless. Boundless. That's a powerful word. It connects directly to who these worlds are actually for. These worlds are for players, participants, and stakeholders. Players, that's the obvious one. That's gamers. That's the heritage of the technology, where it came from. But participants, that feels different. A participant implies a different kind of relationship with the software than a player has. A player is usually trying to win something. They have a score, an objective. They're trying to beat the system. A participant might just be experiencing it. Think about a training simulation for a surgeon or a pilot. They aren't playing a game. They're participating in a simulation to learn a skill. If a surgeon messes up in the simulation, they don't get a game over screen and lose a life. They get a detailed lesson in human anatomy. They're there to experience the consequences in a safe space. Or think about someone attending a virtual concert. They are a participant. They're there to be present, to feel the energy, not to compete. And then there's stakeholders, the most important one. Imagine an architectural firm designing a new international airport, a massive, multi-billion-dollar project. The stakeholders are everybody. The investors, the city planners, the safety inspectors, the engineers, the fire marshal. And usually you show those people a blueprint, maybe a static 3D render where a camera flies through on a predetermined path. The fire marshal has to look at a drawing and try to imagine, okay, if there's a fire here, can people get out? It requires a lot of abstraction, a lot of imagination. You're just hoping they imagine it correctly. But what if you can build a truly expansive world, a perfect digital twin of that airport, a one-to-one scale model, before a single brick is laid? Now, those stakeholders can actually explore it. The fire marshal can literally walk the escape routes. The city planner can see how traffic flows. The investor can stand in the main terminal and feel the scale of their investment. By including that one word, stakeholders, I am explicitly telling you that this engine isn't just a toy. It's not just for fun. It's a tool for industry, for enterprise, for serious decision-making. It takes the technology out of the basement and puts it in the boardroom. But that raises a massive technical problem. If I'm building a city for a city planner or a giant open world for a game, and I have to think big, really big, how do I actually fill it? One thing you need is the space. Another, the stuff to put in it. I would say content that scales. And this is what I would call the empty world problem, a classic creative nightmare. If you tell an artist, hey, I need you to build a world the size of London, their first reaction is probably a panic attack. Because if you have to hand place every single brick, every trash can, every street lamp, every blade of grass, it would take a lifetime, more than a lifetime. You'd need an army of artists the size of an actual army. So, content that scales implies a whole new way of thinking about assets. It suggests proceduralism, systems that can generate detail intelligently. It means you can have a single leaf on a tree that looks incredible when you're standing right next to it, holding it in your hand. That's the micro scale. But that same tree, and thousands of them, still work, still perform when you zoom out to view the entire forest from a helicopter. That's the macro scale. The content needs to work at every level of detail. The technology has to be smart enough to show you the leaf when you're close and just a green speck when you're far away, without the artist having to make 10 different versions of the tree. That's consistency and efficiency. Whether the world is the size of a single room or the size of a planet, the tools and the assets need to support that range. Without content that scales, you'd have to choose. Do I want a small, detailed world or a big, empty one? The thing here is that you no longer have to make that choice. You can have both, big and detailed. And this expansiveness connects directly to the act of exploration. Create truly expansive worlds for your players, participants, and stakeholders to explore. The environment isn't just a backdrop, not just set dressing. It's a territory. If you're watching a movie, you can't explore the background. You only see what the director shows you. If there's a pile of trash behind the hero, you'll never see it because the camera never turns around. But in these expansive worlds, the user decides where to look. They're the director of their own experience. And that changes the entire burden of creation. You can't just paint the front of the building anymore. You have to build the back of the alleyway too, because someone will wander back there. You have to build the sewer grate and the gum on the pavement. It's terrifying, honestly, which is why the Think Big mandate has to be paired with the technology to make it possible. Section 2, Fidelity. Leverage the game-changing fidelity. Fidelity is a word you hear with high-end audio gear, high-fidelity sound. But here I am talking about visual fidelity. At its core, fidelity just means truthfulness. How true is the digital representation to the physical reality it's trying to mimic? Think about incredibly immersive and realistic interactive experiences. I want to pause on immersive because it connects immersion directly not to artistic style, but to technological capability, specifically to the fundamental physics of light and geometry. And there are two features, Nanite and Lumen. Let's start with Nanite. It is a generational leap. To understand why, you have to understand the history of 3D graphics. Since the 90s, everything in a 3D world has been made of polygons, little triangles. To make a curve, you need lots and lots of tiny triangles. To make a flat wall, you only need 2. And you have a budget. Not a money budget, but a polygon budget, a geometry budget. For 30 years, every artist has lived in fear of that budget. If you use too many triangles on a rock in the corner, the game slows down. The whole experience suffers. So what did artists do? They spent decades getting incredibly clever at faking detail. Take a low-detail rock, a simple blob, really, and essentially paint a very detailed picture of a high-detail rock on top of it. It's a trick, an optical illusion. When you're playing a game and you look really closely at a textured wall and it suddenly looks blurry or flat up close, that's you seeing the trick. That's the budget running out. You've gotten too close to the illusion and it's shattered. Nanite is the solution to this fundamental problem. It allows for what they call virtualized geometry, which in simple terms means it removes the polygon budget. It allows artists to take film-quality assets, the kind of models used in Bollywood or Hollywood blockbusters with millions and millions of polygons, and put them directly into the engine in real time. You want a gravel driveway where every single pebble is a real, distinct 3D model with its own shape and shadow? Nanite says, go ahead, we can handle it. That feels like it breaks the rules of how computers are supposed to work, and in a way, it does. But having incredibly detailed objects is only half the battle. You have to be able to see them properly, and that brings us to Lumen, the other half. Nanite is the object. Lumen is how we see the object. Lumen is all about light. Lighting seems like it should be simple. The sun is up there, the light comes down, it hits the floor, done. But that only feels simple in the real world because our brains and the universe handle the physics for free. Inside a computer, calculating light is one of the most computationally expensive things you can do. Every time a single photon of light bounces off a wall, the computer has to do math, and light bounces billions of times a second. So, how did we handle that before? We faked it again, with a technique called baking. Think of it exactly like baking a cake, or maybe more like firing pottery in a kiln. You, the artist, set up all your lights in the scene. The computer then spends hours, sometimes days, calculating exactly where every shadow will fall, how light will bounce off a red wall and tint a white floor. And then it bakes all that information into the texture of the floor. It becomes part of the paint. It's frozen in place, and it looks amazing, as long as nothing ever moves. There's the catch. If you move a chair, the shadow of the chair stays on the floor where it used to be. If you open a door to a dark room, no light spills out. It breaks the immersion instantly. It screams at your brain, "This is fake." It shatters the spell. Lumen is the opposite of baking. It's a fully dynamic global illumination system. It calculates all of that light bouncing around in real time, every single frame. So if you open a door, the light floods into the room naturally. It bounces off the red carpet and turns the white walls slightly pink, just like in real life. If you move the sun across the sky, all the shadows move and stretch realistically. It stops being a static painting and starts being a living simulation. These technologies help bring to life. A static world, no matter how high resolution it is, feels dead, like a museum exhibit where everything is glued down and you're not allowed to touch anything. It's brittle. A dynamic world feels like an ecosystem. It feels like a place that has rules and continues to exist even when you aren't looking at it. That is the generational leap being promised, a shift in the goalpost from photorealism to presence. It's relatively easy to make a realistic picture if nothing moves. It's incredibly hard to make a realistic place that you can poke and prod and change. As soon as you let someone interact with the world, you introduce chaos. The lighting has to adapt. The shadows have to move. Objects have to react. Nanite and Lumen finally solved this problem at a massive scale, allowing extreme fidelity to coexist with extreme interactivity. By the way, if this is actually helping you understand a bit better, hit like and subscribe if you want to keep building along with the series. Section 3, the workflow. So we have massive worlds, the scale, and they look incredibly real and behave dynamically, the fidelity. Who creates all this? How long does it actually take? Because if I have to model every single pebble for Nanite to render, even if the engine can run it, can I, as a human being, actually build it in my lifetime? That brings us to the third pillar, the workflow, the creative revolution. I want to talk about the problem it's meant to solve, which is to eliminate round tripping. Round tripping sounds like a travel itinerary. In this digital world, it's a bottleneck, a massive, soul-crushing bottleneck. It is a pain point for creators. Imagine you are an animator. You've built a character, put them in the game world, had them walk up a flight of stairs, and you notice the animation looks weird. The foot clips through the second step. In the old way, you can't fix it there. You can't just reach in and adjust the foot. You have to close the engine, open a completely separate animation software, load the animation file, and then you have to guess. You have to guess what the stairs looked like because you can't see the game world anymore. You're back in a gray, empty void with just your character. So you tweak the animation, save it, export it in the right format, go back, open the game engine, import the new file, and then check if your guess worked. If it didn't, you do it all over again. That whole loop is one round trip, and you might do that 10, 20, 50 times for one tiny interaction.
Think of it this way. Imagine you're painting a masterpiece, but every single time you want to change the color of a tree, you have to leave the room, drive to a different studio across town, mix the paint there, drive all the way back, and then apply it to the canvas. You'd give up painting. It breaks the flow. It breaks the creative spirit. When I say eliminate round tripping, it means a cure for that specific, very painful headache. It means you can do the work inside the engine, which leads right back to that heading: animate and model in context. Instead of driving to the other studio, you're just standing there painting directly on the canvas. You are seeing the character in the world with the game-changing fidelity lighting from Lumen that we just talked about while you are animating them. You see the result instantly in its final form. That is what context means here. You aren't creating in a gray void. You are creating in the final environment.
There are some specific tools to make this real: artist-friendly animation, authoring, rigging, retargeting, and runtime tools. Also, a continually expanding modeling toolset. Let's look at a couple of those. Retargeting. That's a huge time saver, a force multiplier. Say you spend a week creating a perfect walk cycle, a realistic animation of a human walking. In your world, you have 500 different characters in a crowd scene: a tall man, a short woman, a child, a big bulky robot. Traditionally, you might have to reanimate that walk for every single skeleton. With a good retargeting tool, you take that one animation and the software intelligently retargets it to the unique skeleton of all the other characters. The robot walks with a heavy, clunky gait. The child walks with shorter steps, but it's all based on that one core piece of data you created. It allows you to populate that massive world we talked about in Section 1 without hiring 1,000 animators. And then there's rigging, the process of building the digital skeleton inside a model that allows it to move in the first place. Traditionally, that's very technical, very difficult. These tools are artist-friendly. It implies a democratization of high-end technology. For a long time, game engines were for programmers, for engineers. If you wanted to do something complex, you had to write code. You had to be a technical person first and an artist second. Artist-friendly implies visual interfaces, drag and drop, sliders. It means you shouldn't need a degree in computer science to make a character move beautifully. The tools should be accessible to the person with the actual vision. And then there is modeling itself, a continually expanding modeling toolset. Modeling, the actual act of shaping the 3D object, digital sculpting, is almost always done in external software. Unreal Engine has its own tools to do this natively. What they're saying is you don't have to leave. They are trying to become the one-stop shop. They want you to stay in the ecosystem from start to finish. The ultimate goal is reduce iteration and eliminate round tripping, speed up the creative process. Now, you can never fully eliminate iteration. Creation is iteration. You try something, it's not quite right, you try again. That's the whole process. But you can dramatically reduce the time it takes per iteration. If checking your work takes 1 second instead of 10 minutes, you can iterate hundreds of times more in a single day. You have more chances to get it right. You can experiment. You can play. Speeding up the creative process isn't just about finishing the project faster so you can go home early. If you spend 90% of your time fighting the software and moving files around, you only have 10% left for the actual art. If you can flip that ratio, the quality of the work just skyrockets. You aren't just building faster. You are building better. Synthesis, how it all fits together. So we have the big scale, we have the real fidelity, and we have the fast workflow. How do these three pieces actually fit together? They're completely interdependent. Think of them as a three-legged stool. If you take one leg away, the whole thing collapses. You cannot view them in isolation. You could have the fidelity without the workflow. For years, that's exactly what we did. We made tech demos.
little beautiful rooms that ran at 2 frames per second. But imagine you want to think big, really big, massive, expansive worlds with game-changing fidelity. Lumen, Nanite, all of it. If you don't have the efficient, artist-friendly workflow, that project is simply impossible. Not just hard, impossible. Too expensive, too slow, too technically difficult for any team to complete. The workflow is the enabler. The artist-friendly tools are the bridge between the ambition, think big, and the result, immersive experiences. Without eliminating round-tripping, without making things faster, the other two pillars are just unattainable dreams. They're just marketing bullet points. The 3 pillars together create an ecosystem where ambition is actually encouraged to meet capability. And there's one more term from the workflow section worth pausing on: runtime tools. Runtime means while the application is running, while the game is playing, while the simulation is active. Traditionally, there's a hard line. You build the game, you compile it into a final product, and then you play it. The building phase stops when the playing phase starts. Runtime tools suggest that line is blurring, that you can edit and modify the world while people are already inside it. Let's go back to the airport example. The stakeholder is walking through the virtual terminal in a VR headset. They stop and say, "I don't like this wall here. It makes the space feel too cramped. Move it back 5 feet." In the old world, you'd say, "Great feedback. Let me make a note. Come back next week after I've recompiled and rebaked all the lighting." With runtime tools, you could potentially grab that wall, move it back 5 feet right in front of their eyes, and Lumen would recalculate all the lighting instantly. You don't have to come back next week. You change reality in real time. That is mind-bending. It implies the world isn't a static thing anymore. It's malleable. It's alive. It blurs the line between creator and participant even further. The world isn't a static file you download. It's a living software environment. So let's wrap this up. We've seen the 3 core promises, the trifecta. 1, infinite scale. Think big, really big. The move from claustrophobic boxes to boundless territories, all built with content that can scale from a single leaf to a whole forest without breaking a sweat. 2, realistic visuals. Nanite and Lumen delivering a generational leap in fidelity. The crucial move from baked, static, fake lighting to a dynamic, living simulation of light that breathes and reacts as if governed by actual physics. 3, a unified, fast workflow. No more round-tripping. Artist-friendly tools, rigging, retargeting, modeling, all designed to speed up the creative process so you can build better, not just faster. It's a compelling, holistic argument for the future of digital content creation. And maybe you're not a game developer. Maybe you're not an architect. Maybe you just like watching movies or playing the occasional game. It still matters because the bar for what we expect from digital reality has just been raised fundamentally. Whether you're consuming this as a gamer, using it for training at your job, or just watching the next blockbuster, because virtual production in Hollywood uses this technology constantly, the standard has shifted. The uncanny valley is getting smaller. That feeling when something looks almost human but not quite, and it just feels creepy, that valley is narrowing. We're moving away from "it looks like a video game" toward "it looks like life." The technology is becoming invisible, and you're already seeing it. When you watch the weather report, that 3D map of the hurricane is probably made in Unreal Engine. When you watch a car commercial, that car driving along a mountain road might not be real. It's rendered in Unreal Engine. The line between the real and the rendered is blurring. It's evaporating. And that brings me to a final provocation to leave you with. There are worlds that are infinite in scale, that look photorealistic, and that are fully dynamic. If we are truly moving toward digital worlds that look like ours, that behave according to the same physical laws as ours, and that are big enough to get lost in for a lifetime. Are we approaching a point where the digital world becomes indistinguishable from the physical one for those participants? When the fidelity is truly boundless, reality becomes just a matter of perspective. And if you genuinely can't tell the difference, does the difference even matter anymore? Something to think about next time you look out at the horizon and wonder if the mountains are real. Drop your comments below. Thank you for listening and watching. See you next time.